Hello, everyone. I'm Matt Rosenbloom. I'm a senior in the analytics program here at Wake Tech, and I'm also currently working on my computer science degree at NC State. I'm going to be presenting to you on the Titanic Kaggle competition that was just mentioned to you. Just a little bit of background information. We first approached this particular competition in one of the very early classes in the program. At the time, we were only really familiar with the most introductory techniques, and I chose to re-examine it in the 6th out of 8 classes here, just as a measure of the progress that I had made so far. And here's the basic information about the data set. Your goal is to predict whether or not a passenger survived, and you were provided with information about the passenger, such as the passenger class, their name, gender, age, several variables representing the number of family members traveling with them, their ticket number, fare, cabin, and the port from which they embarked. And the very first thing I did when I started to re-examine this competition is sometimes the Kaggle competitions are accompanied by an introductory guide of some sort, and one of them suggested extracting all the titles out of the name field and then grouping them based on the social standing of the passengers. And that turned out to be a really valuable variable, and I thought that was really cool at the time. It was like finding hidden value in the data set that wasn't there before. And prior to this project, I had been focused mostly on mastering the techniques and learning the software. This was one of my first real experiences with creative feature engineering, and I became kind of fixated on it. I wanted to find more hidden value in the data set, and I wanted to come up with some features that I could engineer on my own. And to begin doing that, I looked for the variables that I thought had a lot of untapped potential in the data set, and those were the cabin number, the fare, and the variables related to family size. The cabin number was a high potential variable. It seemed intuitive to me that the passenger's location on the ship would be related to their chance of survival. Unfortunately, in the data set, 77% of the records were missing the cabin information. So I wanted to come up with a way that I could kind of infer where these passengers were located on the ship. And initially, I assumed that the best way to do that would be using the fare prices. I assumed people on the same deck would pay similar ticket prices. And so I examined that, but it turned out that that was in fact not the case. For example, on C deck, the passenger fares ranged anywhere from 8 to well over 200. And I became really curious about why this was. So I started to research, and I found a map of the ship, and I quickly learned that rather than having decks that were limited to first-class passengers or second-class passengers, all of the first-class passengers were situated in the center of the ship because that area of the ship was less affected by the rocking of the ocean. They didn't want their most important passengers getting seasick. And then the front and back of the ship were mostly second and third class cabins. So that kind of ruined my plan to use the fare prices to infer the decks that these people were on. So I had to come up with a new strategy. And what I did was I started to examine maps of each deck individually. And I would go in, this is the C deck midship. These are all first class cabins, but you can see even within one class of cabin, there's significant variation in the room quality. For example, the outer rooms are, they have a window, they're much larger. The inner rooms are smaller, and at the other two ends of the ship, there's some even smaller accommodations. And what I did was for each deck, I looked through and I found the ranges of numbers that represented these groups of cabins that I felt would have similar fare prices, similar desirability. And I created algorithms that would place the existing cabin numbers into these groupings to allow me to get better information about what these rooms might have cost. I did this for all of the decks on the ship, with the exception of G and T deck, which were extremely small and underrepresented in the data set. Okay. And the outcome of this method really helped to explain a lot of the variability in ticket price. You can see the chart on the top here is the average fare and standard deviation for just the C deck before the grouping method was performed. And obviously that amount of variability makes it basically useless for inferring where someone was located. Whereas when the cabins were split into their relative groupings, there was a lot less variability in the data. I could use this to kind of infer where people were located on the ship. And in addition to that, I also separated the existing cabins into a side when I could for port or starboard of the ship. And the reason that this became relevant is I learned in my research that the evacuation on the two sides of the ship was actually handled differently. One side was much more strict about enforcing the women and children first policy, so obviously that could come into play with survival rates. And the last thing that I did was I tried to identify family groups on the ship, and I did this by, first I added together all the variables that represented passengers of the family that were accompanying them. It was spouses, children, parents, and siblings. and I added one for the person themselves, and that was a group size variable that I created. I also extracted the surnames, and I used those two things combined with the port of embarkation to uniquely identify family groups. There's an example of this here and an example of why this is useful. The top 5 records were all in the training data, so we knew the outcomes for those people. None of them survived, and young Master Albert Rice was in the test data set. So I think you can tell from these results that things probably didn't go very well for him. But in addition to this, some other interesting relationships became apparent. For example, family groups that had a known adult male survivor had a slightly increased survival rate for the remaining family members, because that probably indicated that they got to the lifeboats early in the process before they were more strict about the women and children policy. And the end result of all of this and all this feature engineering was most of the variables that I created were useful in model building. It was a random forest process. And after most of the family group variables were useful. All of the ship location variables were useful, in addition to most of the variables from the starting set, age and gender, passenger class, and things like that. And after some tinkering, I was able to obtain about 83% accuracy predicting survival on the Titanic, which ranked me 31st out of more than 3,000 teams in the competition. Thanks.